Hello students. In this video, we will solve some numericals of your unit 5, that is friction. Now, the course outcome we are trying to achieve here is you should be able to apply the principles of friction in various conditions for useful purposes. And there are some prerequisites to learn this topic. You should be familiar with the concept and technical terms related to friction and resolution of forces. So, I would recommend you briefly go through the video that explains all the theory of this Unit 5 friction of engineering mechanics and then start this video. So, let us get started with the examples. Now, consider this first example. Find out magnitude of a push inclined at 30 degree to the horizontal required to move a block weighing 500 Newton resting on a horizontal surface having coefficient of friction as zero point 0.2. Now, there are so many things in these lines. So, first thing you need to do is you have to draw a figure considering all this information. So let us go through them one by one. What you need to find out is magnitude of push. Okay, you need to find out magnitude of push. That means there is a force P which is applied on the block, and you need to find out that P force. It is applied at an inclination of 30 degree to the horizontal. Now, in this case, your surface is horizontal. The surface on which block is resting is horizontal. So, let us draw the surface first. Right, you draw a simple horizontal surface, and a block is resting on the surface, and weight of the block is 500 Newton. So, we will draw a block here, and weight of the block that acts downwards is 500 Newton. Okay. Next, you will draw this push. Push is inclined at 30 degree. So, I will draw a force P at an angle 30 degree with horizontal, and which will be in the direction as it is pushing this block. Okay. Now, another reaction you will get for this 500 Newton weight is the normal reaction N. Reacting to the weight, you will get normal reaction from the surface. This is the surface, you will get N. Now, if you are pushing the block this way, the friction will act in the opposite direction. So friction F will act opposite to the motion, right? So these are your forces. Now you have F, N and 500 all aligned to horizontal or vertical direction. This force P is inclined at 30 degrees. So what you need to do is you need to resolve this force P in two component, one vertical and one horizontal component. So let us make two shadows of this force P. One will be horizontal shadow, okay, which will be adjacent side to the P. So I will call this P cos 30 degree, and other shadow will be here, vertical shadow of this force P, and this is opposite side to P, so we will call this P sine 30 degree. So now your force P is resolved into horizontal and vertical directions. So you don't need to consider this P while calculating. You will consider two components of it. Okay. And other thing given here is coefficient of friction is given as 0 0.4. So that is your mu. Coefficient of friction is mu, that is given as 0 0.4. So let us start solving this. First you will resolve forces parallel to the plane. Okay. First resolve forces parallel to the plane. So I will write this: resolve parallel to the plane. Now in this direction, what forces you get? First is this F force, another is this P cos 30 degree. Okay, first force is F, another is P cos 30 degree. There is no other force working parallel to the plane, so we will get F is equal to P cos 30 degree. Okay, this is your equation number 1. Now I will resolve forces perpendicular to the plane. Okay, resolve perpendicular to the plane. Now resolving perpendicular to the plane, you will get three forces. first is this weight 500 Newton, another is normal reaction to this weight, that is n, and another is this p sine 30. Now this p sine 30 is coming downwards, weight 500 is downwards, and this n going upwards. So I will write it as n is equal to 500 plus p sine 30 degree. This is my equation 2. Now solving this 1 and 2, I need to find out force P. But here we have three unknowns, F, P and N. Three unknowns and only two equations. So we cannot solve as it is. We will use this mu. Okay, we will use this mu is equal to 0.4 to solve this system. So you know that mu, coefficient of friction, is F by N, is given here as 0.4. So from this equation, we will remove one variable here. Okay, we will remove one variable here. So let us consider n is equal to, okay, n is equal to f by 0.4, that will be 2.5 f. From this you get n normal reaction is equal to 2.5 f. Right? Now I will put this value of n is equal to 0.5 f in this equation number 2. In this equation number 2, 2.5 f. Okay, now take this p sine 30 this way, so it will be minus sine 30. We know that sine 30 is 0.5 into p is equal to 500. Simplifying, you get this equation as replace n with 2.5f and minus 0.5p is equal to 500. Now the other equation, we have this one. Okay, the other equation is f. Again, take this p cos 30 on the other side, so minus 0.866p cos 30 is 0.866 p is equal to 0. Now these are your two equations and you need to find out p. So what will we do? We will eliminate this f. So to eliminate this f, you need to multiply this equation with 2.5. This second equation, we will multiply it with 2.5. So first term you will get is 2.5f. Now multiply 0.866 with 2.5, you will get 2.165 p is equal to, multiplying 0 with 2.5 is 0, so is equal to 0. Now this is your equation 3, let's say it's 3 and this is 4. You simply need to do is 3 minus 4. Okay, equation 3 minus equation 4. So change all the signs here. This will be minus, this will be plus, and 0 has no sign. So you will get, okay, don't consider this now. We don't need to consider this middle equation now. You are subtracting this equation 4 from equation 3. So you will get 1 point, this is 2.5 f minus 2.5 f, this is 0. Here you will get minus 0.5 and plus 2.165. So net you get 1.665 p is equal to 500 minus 0, that is 500. Okay, now solve this. P is equal to 500 by, P is equal to 500 by 1.665. So you get P is 300.3 Newton. This is your answer. P is equal to 300.3 Newton. Okay, so what you need to be careful about is, you need to first see whether the surface is horizontal or surface is inclined at some angle, whether P force is horizontal or it is inclined, and at what angle P is acting, whether it is push or pull, and F force will, frictional force will always be opposite to the motion. We will solve some other examples and things will get clearer. Okay, so let us move to next example. Now the second example, a block weighing 5 kilonewton is lying on a rough plane inclined at 25 degree with horizontal. So from this first line we get that the surface is not horizontal now, it is inclined at an angle 25 degree with horizontal. Okay, so I will draw a horizontal line and a surface that is at 25 degree with this horizontal line. Okay, Now this is my rough surface and block is resting upon this. The block is resting upon this inclined surface and weight of the block is 5 kilonewton. So weight will act vertically downwards. So this is 5 kilonewton weight. Next thing given is angle of friction, that is 20 degree. Now angle of friction is phi. Angle of friction, that is phi, that is 20 degree given. Find minimum force required parallel to plane just to support the body. Now understand this line carefully. What do you mean by supporting the body? That means that you are preventing it from sliding down. That is the meaning of support the body. So the intended motion is downwards. Your intended motion is downwards. You are applying a force P upwards. Okay, a force P upwards is applied to stop it from falling down or sliding down. That is the meaning of support the body. Now, when the movement is the intended movement is downward, the force F will also act in the upward direction. So in this example, your P and F both are acting in same direction, both are acting in upward direction. Remember, F is not always opposite to the P. F is opposite to the motion. Here motion is downward, so F is upwards. And P and F both are in same direction. And what we need to find out is this force P. So let us draw another force, that is normal reaction N. Normal reaction N will always act in direction perpendicular to the surface. Now you need to make two components of this weight. Two components of this weight 5 kilonewton, because you will be solving parallel to the plane and perpendicular to the plane. So P, F and N all are aligned either parallel or perpendicular to the plane. Only this force 5 kilonewton, weight 5 kilonewton is not aligned. So we will draw two components of it. First is this, another is this. Consider these as shadow of this 5 kilonewton. Now if this angle is 25 degree, this will be your 25 degree. And this is adjacent side, so I will write this as 5 cos 25 degree. And this will be 5 sine 25 degree. Okay, these are your forces now. N, P, F, 5 sine 25 degree and 5 cos 25 degree. We don't need to consider this inclined force 5 kilonewton anymore. We will consider two components of it. Okay, so now coming here, we will use this angle of friction to find mu. Mu is 10 of phi, right? So mu is 10 of 20 degree, and you will get it 10 of 20 degree as 0.364. That is our F by N. We will use it later. This is F by N, that is 0.364. Now first consider forces perpendicular to the surface. Forces perpendicular to the surface. So I will write it resolve perpendicular to the plane or surface. Okay, perpendicular. In perpendicular direction, we have only two forces. First is N, that is going upwards, and second is 5 cos 25, that is going downwards. So from the condition of equilibrium, we can say that these two will be equal. So simply you get N is equal to 5 cos 25 degree, and solving this you will get N is equal to 4.53. Okay, 4.53 kilonewton. Whatever is unit of this force, weight or P or whatever one force will be given, the unit of that force will be unit of the answer. So N we get as 4.53 kilonewton. Now let us resolve parallel to the plane. Resolve parallel to the plane. So what are the forces we see parallel to the plane? First is this 5 sine 25 degree, and other two are P and F. These are going in upward direction, this is downward direction. So again, applying equilibrium condition here, we get P plus F is equal to 5 sine 25 degree. Okay, now to calculate this F, we will use this. Now you have N, you need to find F. You know that F by N is 0.364 and N is equal to 4.23. So you will get F is equal to 0.364 into 4.53. F I'm getting as 1.65. Okay, F here is 1.65 kilonewton. Putting this value of F here, putting this F here, you get P plus 1.65 is equal to 5 sine 25 degree. Now take this on the other side and subtract from 5 sine 25 degree. You simply get P is equal to 0.464 kilonewton. That is your answer. P is equal to 0.464 kilonewton. Okay, so in this example, our surface was inclined, block was intending to move downwards, and we were just supporting it from falling down. So P and F both were in same direction. Okay, this is the other variety. Now let us move to third example. Third example. So a body of weight 700 Newton rests on a plane inclined at 15 degree to the horizontal. This is simple now. We have understood this, that first we will draw a horizontal line, then we will draw our rough surface which is at angle 15 degree from the horizontal line. A block is resting on this. Okay, and weight of the block which acts vertically downwards 700 Newton. Okay, weight of the block is 700 Newton. A force of 450 Newton is just sufficient to cause the body to start moving up the plane. Again, moving up the plane means movement is upwards. Intended movement is upwards. So you are putting a force 450 Newton, right? This 450 Newton is responsible for the upward movement. So friction will act downward. Friction is always opposite to the motion. So movement is upward, friction is downward. And one more force you will get is N, normal reaction N, which will be normal to the surface, this rough surface, normal to the surface. Now again, F, N and 450 all are aligned parallel or perpendicular to the surface. Only this 700 is inclined. What we need to find out is coefficient of friction. So mu, coefficient of friction, mu is to be found out here. Now I will divide the 700 Newton weight in two components. Okay, 700 Newton weight in two components. First is this. Now if this is 15 degree, this will be 15 degree. So 700 cos 15 degree, as this is adjacent side, and other component will be this way, which will be 700 sine 15 degree. Now your forces are N and 700 cos 15 perpendicular to the plane, and F 700 sine 15 and 450. These three forces parallel to the plane, and you need to find mu, coefficient of friction. So again, let us do the same thing. First we will resolve forces perpendicular to the plane. Okay, perpendicular to the plane, N is equal to 700 cos 15 degree. That's simple now, 700 cos 15 degree. So I'm getting N as 676.15 Newton. Right, then we will solve parallel to the plane. Now parallel to the plane, F and 700 sine 15 both are coming downwards. So these two we will write on one side, and on other side we will write this 450. So F plus 700 sine 15 degree is equal to 450. Now solving this, you get F is equal to 268.83 Newton. Now we know that mu, that is coefficient of friction, mu, formula for mu is F by N, right? So you will simply do this F 268.83 by N, that is 676.15, and we will get mu as 0.398. Okay, 0.398. This is your coefficient of friction. Now suppose in here it is not asked, but if they asked to find out angle of friction also, angle of friction is phi. If phi is also to be found out, then we will do one step more. We know that tan phi is mu. So we know that tan phi is 0.398. So phi is tan inverse of this. Okay, simply tan inverse of this. So let us do tan inverse of 0.398. I'm getting it as 21.7 degree. Okay, 21.7 degree. So what was asked here? Coefficient of friction, we are getting it as 0.398. Let us see one more example. Find the weight of the block. Right, find the weight of the block if a force of 50.5 Newton is required to lift a block up an inclined surface making an angle of 30 degree. So here you have an inclined surface. First draw the inclined surface. This is our horizontal line and this is the inclined surface which is at 30 degree from horizontal, and rest a block on this surface. Weight you don't know, weight you need to find out. So we will write it as W. Weight will act vertically downwards, it will be W. A force of 50.5 Newton is required to lift a block up. Means we are applying 50.5 Newton force to lift it up. So movement is upward, friction will be downwards. Okay, movement is upward, friction will be downward. And this is your normal reaction N. So these are the forces. Coefficient of friction mu is also given as 0.2 here. Again, you will resolve this W in two components. This W in two components. This will be your angle 30 degree. So W cos 30 degree here and W sine 30 degree this way. Okay, so these are your forces now. N F 50.5, W cos 30 and W sin 30. Again, do the same thing, resolve parallel and perpendicular to the plane. I will write mu here. Mu is given. Okay, mu is equal to 0.2 is given. So F by N is 0.2. This much is given. Now resolve perpendicular to plane. In perpendicular direction, I'm getting two forces, N and W cos 30 degree. So these two will be equal by the condition of equilibrium. Sorry, not sine, W cos 30 degree. This is one condition. Other one is resolve parallel to the plane. Okay, resolving parallel to the plane, you are getting three forces here. You have F, W sine 30 both going downwards and 50.5 that is going upward. So F plus W sine 30 degree is equal to 50.5. Okay. Now from these two equations, you need to find out W. Again, we will use this. F by N is 0.2. So we can say that from this, you can say that F is equal to 0.2 N. Just take N on the other side. In multiplication, you get F is equal to 0.2 N. So I will replace this F with 0.2 N here. So 0.2 N plus W sine 30. Sine 30 we know sine 30 is 0.5. So 0.2 N plus 0.5 W is equal to 50.5. This is one equation. Other equation is here N. Let us take this W cos 30 on the other side. So minus 0.866 W is equal to 0. Okay, now from these two equations you need to find W. So you will multiply this second equation with 0.2 and then subtract equation 2 from equation 1. I am not showing this calculation here as you have understood in previous example. So this is a basic elimination method, and by elimination method you will get W is equal to 75 Newton. This is your answer. W is equal to 75 Newton. So this is how you find out weight of a block if it is not given and you are given the P force. So these are some simple examples. If you understand how to draw the figure from the question and then how to resolve forces along parallel and perpendicular direction, you will easily get the unknowns, right? So thank you.